So for number 4, we are going to solve for gateway address. We are given the network address 10.1078.128 with the prefix /25, which we have solved earlier. First, we convert the prefix to its subnet mask, which is um, this 255.2 to 255, and so on. Then we calculate the block size by subtracting 128 from 256, giving us 128. This tells us that the subnet ranges from 10.1078.28 to 10.10.78.255. Since the network address is reserved, the first usable IP address is 10.10.78.129. Therefore, the gateway address should be 10.10.78.129. So for number 5, we're going to convert each decimal octet of the IP address into its 8-bit binary equivalent. So 192 becomes 110000, 84 is 810101010, and then 235 becomes 11101011, and 0 becomes 8 zeros in total. And then this is how we solve it. We get the first 8 octets and solve it like this until we get 0. And then we do the same with 82. Then we do the same with 235 and 0. So the answer is 110000000.01101010011000000. Number 6, we are looking for the broadcast address. So the given network address is 192.84.235.0. The prefix length of /24, which means the first 24 bits represents the network and the last 8 bits represent the host portion. To find the broadcast address, we set the host bits to 1 in decimal, 8 ones in binary to equal to 255. Since only the last octet changes, the broadcast address becomes 192.84.235.255. This is the last IP address in the network and is used to send data to all devices within the same subnet. So for number 7, we are asked to find the prefix length using the given subnet mask 255.255.255.192. To solve this, we first convert the subnet mask into binary forms, and then we count all the ones because the prefix length is simply the total number of consecutive ones. So we have 8 ones for each 255. We all have 8, and the first 3 octets, we have 8 ones in each for the first 3 octets, which gives us 24, and the last octet has 2 more ones, making it a total of 8 plus 8 plus 8 plus 2 is equal to 26. And the correct prefix length is /26. So for number 8, we're going to solve for broadcast address. We are given the network address 172.99.184.64 with a prefix length of /26. /26 subnet has a subnet mask of 255 and so on, 0.192, which gives us a block size of 64. So this means the subnet ranges are from 0, 64, 128, and 192. Since our network starts at 172.99.84.64, the subnet begins at 172.99.184.128. The broadcast address is always the last IP address before the next subnet, so we subtract 1 from 172.99.184.128, giving us 172.99.184.127. Therefore, the broadcast address is 172.99.184.127. So for number 9, we are asked to convert the network address 205.36.72.56 to binary. So we convert each octet separately using the binary place values 128, 64, 32, 16, 8, 4, and 2, and 1. So the first octet is 205, 11001101. The second number 36 becomes 00100100. Then 70 becomes 01001000. And 56 becomes 00111000. After combining all 4 octets, the binary IP address is 11001101 001001000 01001000 00111000. So for our last problem, we want to solve for broadcast address again. We need to find the broadcast address of the network 205.36.72.56, the prefix length of /29. First, we determine the block size by subtracting the last octet of the subnet mask from 248 from 256. This gives us a block size of 8, so the subnet ranges increase by 8. Since our network starts with 205.36.72.56, the next subnet begins at 205.36.72.64. The broadcast address is always the last IP address before the next subnet, so we subtract 1 from our address here. So 64 minus 1 becomes 63. Therefore, the broadcast address is 205.36.72.63.